This is Geometry, Semester 2. It's the third unit called Solids, and it's the 8th lesson, Volume of Spheres Practice. It's on creatormath.com. Make sure you're under the Geometry tab. You're on the table of contents. It says copy the following problems 1 through 4. Follow that. If there's more than 4 problems, you do not have to copy them into your comp book. So copy problems 1 through 4 into your composition book on the correct pages according to the table of contents, with the notes for those pages, which is in a separate file on that table of contents you can click into and find the notes. The notes will explain in more detail the concepts we're dealing with right now. Right, so this is just problem sets. I'll run through the problem sets using the concepts, but won't go back through all the concepts. Creatormath.com is where this is found under the Geometry tab. Given the following three-dimensional shape, what is the volume? Hint, the volume of a sphere is 4/3 pi radius cubed, pi r cubed. So spheres, while very complex, I think, to imagine what volume is, and again, volume is if you were to pour liquid into, and a sphere is a three-dimensional shape, right? If you have a basketball, a tennis ball, any kind of ball you have, that is an example of a sphere. It's spelled, interesting, S-P-H-E-R-E-S. I always say, sometimes I feel like when I say sphere, I'd say this in the COVID era, but I'm slightly spitting a little bit, right? So I'm going to wear a mask for sure when I say it. But the word sphere is a little bit funny to say for me. So it's a three-dimensional circle, and the idea of volume is if you could fill it with liquid, how much liquid would fit in there? And of course we need to know things like this, like take the can of Coke, right? If you were at the Coke plant, you had to fill those Coke cans, all those billion Coke cans they produce each year. You're very interested in how much Coke will fit into that can, and is the can the right size, and are you filling it to the right level? That's volume, and that's why it's so important. So when it comes to a sphere, we've got 4/3 pi r cubed. We're going to just take the simple dimension of radius. In this case, it says a radius is 3 inches. Radius is from the center of the sphere to the side. This is 3 inches. So we have 4/3, and again, we don't derive this until calculus. We go back and derive 4/3 pi r cubed. Pi, the only dimension is 3 inches. Put the entire dimension in, 3, the number, and the unit, and then cube it. Cube both the number and the unit. Volume equals 4/3 pi. 3 times 3 times 3. 3 times 3 is 9. Times 3 more is 27. So 27. And inches raised to the power 3 is inches cubed. And that's the reason we drop it in here. And the reason we do this is to confirm that we have a unit for volume. And we do. We have inches cubed. So we're a little bit happier at the moment. Let's take 27 divided by 3. We get 9. 9 times 4 is 36. 36. We still have the pi. It stays in its dimension form of just pi because it's more accurate. 36 pi, and we have inches cubed. We're going to drop that in. That's our unit. So 36 pi inches cubed. Same thing. Volume equals 4/3 pi r cubed. Volume equals 4/3 pi. What's our radius? They gave us a diameter. Wow, that's pretty tricky, but you got to watch it because that's the kind of thing that I do know can stump students. Remember, radius is the half dimension across. Diameter is the complete dimension from one side to the other. There's ways to remember it. You know, I can't remember where I learned this or who even told it to me, but they said R stands for rat and D stands for dinosaur, and the dinosaur is bigger, so it's the bigger dimension, and rat is smaller, so it's the smaller dimension. However you figure out to remember diameter and radius, come up with some system. Diameter is the whole distance. The formula has radius, so we have to take that 6 centimeters, divide it by 2. And you could have just said 3 centimeters, but I'm going to put it actually into the formula so I could type it into my calculator if I need to. I'm going to cube this because that's r cubed. Volume equals 4/3 pi. Let's see what we got here. 6 divided by 2 is 3. And we already said 3 times 3 is 9 times 3 more is 27. So you got 27 here. It ends up being the same thing because we had 3 inches for the radius up here and 6 for the diameter. So it's going to be the exact same answer. Centimeters cubed is centimeters cubed. Good, that's volume. 27 divided by 3 is 9 times 4 is 36. V equals 36 pi centimeters cubed, 36 pi, and here they just wrote the word pi for pi. And looks like same thing. Volume equals, I don't see any variation here, 4/3 pi r cubed. Volume equals 4/3 pi. Radius is 6 feet, okay? 6 feet cubed. So volume equals radius. Well, and so in this case, let's model for you what we're going to do, right? I've got my calculator. It's already turned sideways. Let's try to see both items at the same time. I like this in a single statement. And let's see if I can actually work my calculator to see if I can do this. First of all, feet cubed is going to come out feet cubed. So I'm okay with that. I've got the right units. That's a volume. All right. So this is 6 cubed. So how about, we're going to keep pi the way it is. Let's keep pi in there. So what I have is let's deal with 6 cubed first. Watch this. If you take, let's see if I can do it on my calculator. 6 caret 3, parentheses. That's 6 to the power 3, or 6 cubed. So I have this right here, 6 cubed. I'm going to multiply it by a 4, times 4, and I'm going to divide all of it by a 3, divided by 3. So in one calculation, which is definitely the way I like to do it, I don't want to cube this, then multiply it by 4, then divide by 3. Just let the calculator do all the work for you. It comes out 288. And we have pi feet cubed, 288 pi feet cubed. Right? I do like that one because it forced us to use our calculator to cube something. We could have gone, you know, I'll see students do this, right? They know what cubed is. They'll go 6 times 6 times 6. And they get 216. That's cool. But look, your calculator is literally, they've thought about this for you, right? It's this x to the y key. So if I hit 6x to the y, it allows me to put in any power, including 3. I just keep the parentheses in there to say that that 3 is the power of the 6 equals 216. They're helping us do our job. We got to let them do it. We got to use the tools we have, if at all possible. Given the following three-dimensional, let's do it again. Volume equals 4/3 pi r cubed. Volume equals 4/3 pi. And they keep giving us the formula each time. That's nice. And they even tell us the radius is equal to half the diameter. That's nice. The diameter is 12 centimeters. So we've got 12 centimeters, but that's a D for diameter. We have to divide it by 2, then cube it, because this is radius. So diameter is twice the radius, so divide it by 2, we'll take it back down. So this is going to be 6 again. It comes out just like before, right? So, and maybe just to model this again, the units are going to come out centimeters cubed. The pi is going to come on down. And let's do the calculation, and let's let it calculate it for us again. So pretend we had decimals and something more complicated than the numbers we have. Clear? Let's do this whole thing. We're going to say 12 divided by 2 cubed. Watch this. Parentheses. 12 divided by 2 parentheses. Now caret cubed. Parentheses. So this is doing, if this were something more complex, I might have to do several calculations. I might have to divide it by 2 first, then cube it. I can let the calculator divide it by 2 and cube it all at the same time. I can multiply this by 4 now, and divide this by 3, and I get 288. I know that's right because I already did it on the last calculation. So I get 288 pi centimeters cubed. And I better check my dimensions. This says centimeters, so this is right. So this is not right. They have feet here. These need to be all centimeters cubed. I'll fix that again before you guys get to it. I'll fix that because I'm about a week ahead of you. All right, so 288 pi centimeters cubed. This one. So match up the title of this lesson. Match up the title of the lesson right here, Geometry Semester 2, and this one comes out solids. Number 8 is the lesson. Number 3 is the unit. Volume of spheres practice, and that way you can match up the video with your assignment. And again, it's on creatormath.com under the geometry tab.